It's a new week and it's time for a new science YouTube video. This week we're going to be using Oreo cookies to model how Earth's tectonic plates meet at boundaries and what kind of geographic features form at those boundaries. Remember, you should have done the Introduction to Plate Tectonics assignment before doing this one. It will give you a good background on what we're doing throughout this lab. This week's assignment is more of a model, demo-based assignment, and we're not going to be following the same scientific method that we have been in previous weeks. It's more similar to what we did last week with our rock cycle demo. Remember, in order to get the most out of this, you should be following along in your investigation guide that goes with this video. Let's get started. Here's some background. If you remember from a couple weeks ago, we talked about the Earth's layers. The upper layer is called the lithosphere, which is made out of the crust and the upper mantle. The lithosphere isn't one whole smooth shell. It's made out of broken pieces that are really large and slowly moving. We call these plates. Convection currents occur in the asthenosphere, and these currents move the plates, which kind of float on top of them. Here's a map showing the major plates in different colors and some of the boundaries around the world. These are the materials that you'll need if you're going to follow along in the experiment with me. To start, we're going to open up an Oreo. The layer without any cream is going to represent our lithosphere. We're breaking it in half to represent two plates. The white cream layer represents the asthenosphere, which in reality is a little more liquidy and flowy than our cookie cream. For part 1, we're modeling a transform boundary. In transform boundaries, plates slide in opposite directions, grinding against each other. If you notice, there's some resistance when this happens, and it doesn't move that much until the plates suddenly slide past. In real life, these transform boundaries cause earthquakes to occur. Pause the video here to answer the investigation questions about part 1. For part 2, we're modeling a convergent boundaries. Based on the root con, which means with or together, you can probably guess that for this boundary, the plates are going to move together or towards each other. I wet the edges of our different plates so that you can see what happens when they come together more easily. Pause the video here to answer the investigation questions about part 2. For part 3, we're modeling a divergent boundary. Divergent has the root dive in it, which means separate. The plates are going to separate at a divergent boundary, as shown here. When divergent boundaries occur underwater, we get mid-ocean ridges, and magma can fill in that empty space there. When continental crust separates, we can get rift valleys, which are just valleys that form when two plates separate. Pause the video here and answer the questions about part 3 in your investigation guide. So today we learned about convergent, divergent, and transform boundaries between plates. Earth's plates are constantly moving due to the convection currents in the asthenosphere below the lithosphere. This map shows just some of the ways that the plates interact at its boundaries. You'll be using this map to answer some of the questions that are in the conclusion section of your investigation guide. That's all for today's demo. I hope you enjoyed learning about convergent, divergent, and transform boundaries with me using Oreo cookies today. Make sure you're doing the assignment along with watching the video and turning it in on time in order to get credit on Google Classroom. This week, I want to give shoutouts to Abel F, Jayden, Brianna, Jayden and Brianna for not only turning in 100% of their science work on time so far, but also turning in exemplary work. Make sure you're doing all your assignments so maybe you can get a shout out next week too. That's all for now. Bye!